Okay. Good evening. I hope everyone had a good break and everything. Uh, Today we'll be getting into Docker. So I hope everyone can see my screen, right? All right. Fine. Okay. So let's get into it. So what we'll be looking at today. First of all, we need to understand what Docker is. So we'll begin with that, obviously, and then there are several parts of Docker which are very much relevant to the tutorial, and then I'll explain all of those, some command, and then I'll actually make you do all these. And there will be some obvious questions coming along the way which I will be addressing as well. And I hope by the end of this, whatever questions you have, I might have included it and already thought of it and answered it as well. But if you have any more questions, again, as usual, drop it in the chat or my DM. I'm active on both. All right, so let's get into it. Okay, so what is Docker? Uh, what is Docker? The actual definition, the technical definition is it's just an open source containerization platform which allows it to pack our dependencies and application into something called a container. Now, I just told a bunch of words which may or may not have made sense, right? So I'll help you visualize it as well. Okay, and uh, these containers are really lightweight, like really lightweight, but depending on what you're running in there, it can get heavy as well. That is why you need a good sort of system with a good amount of RAM as well. Okay, and whatever I just told about containerization, packing all the dependencies, and calling it a container, we can also visualize this very simply. Okay, uh, fine. Now let's imagine you have a room, right? You have a room where you have your laptop, your chargers, your headphone, your bottle, and your maybe your table plant, and something you're decorating it as well. But this gives you a really streamlined mind space that it makes you really productive, right? Imagine you have a space like this. I suppose that is where you're sitting right now as well, and I can say that with some level of confidence that it makes you productive, right? Now, if I suddenly want you to move somewhere else, right? To get that same level of productivity, to get the same level of flow that you had in your old setup, ideally you would want to move everything from your current setup as it is wherever they were to the newer setup, correct? But that is a little bit time consuming, right? Moving each of the item, and since you have only one of these, uh, say you wanted to move each of them to a particular spot, and maybe your new apartment or newer space does not have the correct dimension, something like that, right? But all of those little constraints will make it some or the other way lesser productive than your older system. So what if you could just capture an image like this as you see on a screen, and then you tell your builder you want it exactly like this in your new apartment, and not a centimeter less or not a centimeter more. You just want it exactly like this so that you can get back to what you were doing, where you were, back to the same flow and with the same amount of productivity. Okay, so let's introduce the concepts of images. So if you just take this image and you go and present it to a builder that you want a table like this and everything, then uh, he can make it like that for you. Okay, so that's the thing. This is essentially what a Docker image is. So Docker image contain our dependencies, whatever we want to install, maybe a very specific version of that software as well, and uh, say you want to pack it all into one really nice package so that you can hand it to someone else, or maybe yourself to go somewhere else and take it, right? Now from this image you can unpack it and then get your own setup with the same files that you had before, with the same dependencies that you had before, exactly as it was, so that you're not getting disturbed at all, and you can continue wherever you were before. So this is essentially the idea of Docker, to take something that was working on one system, to package it in a very efficient way, and then to put it in another system, or maybe multiple other systems with the same amount of productivity and the same dependencies and everything. The core idea is this: just to copy paste your environment as it was from place to place without disruption. Okay, so that is what Docker is all about, and all of its components help us to do that. It enables it. So Docker images are a part of it, and what it, like I told, it just uh, takes an image. It just takes a snapshot of whatever you were doing at that particular moment, whatever software you had, whatever the versions were, everything. It takes it, packages it, and then you can send it to whoever you want. They can also start working on it. Okay, but imagine you maybe change a chair or a pot in your old setup. So then if you take an image again, it becomes a newer setup, right? It's a fundamentally different one from the older one. So that is what is also being applied here. If even a slight modification is made to your old setup, that becomes a new image entirely, not part of the old one. Suppose you already sent one image, now you change something, that then again you'll take an image and send it to your builder, right? That's the thing. It will be an entirely different image. So your builder will have to consider what changed, what did not, and then he'll have to adjust accordingly and then do it. Correct. So that is images, just to have an idea of what was there before and try to apply it somewhere else. Okay. Now getting to containers. Now suppose you took that image, then your builder built a room in a new apartment, and you're happy with it. It was exactly as it was before. So this is uh, it's not exactly the old setup, but it's somewhat like a duplicate, right? Not a duplicate exactly, but it's a one-to-one copy. So this is what your containers are. Containers, if you're aware, let me take another example from Python. If you have ever worked with Python classes, so classes is what? It's uh, just a way of defining a structure that you want certain variables to behave this way and certain variables to behave some other way, and then you make several objects out of that Python class. So this essentially is what is being applied here as well, just that it includes several other software, right? Now, from your image, you built that same room in like 3 4 different apartments. So to convert it back to our example, that is, we took an image of our current software system, all the apps that we installed, maybe some configuration changes that we made. We took an exact image of it, and now we have that exact same image running in 3 4 different computers. So what is running? Whatever is running currently, you call those containers, because images are just images, but what what makes you use those images are these containers. So it's just a like I told, merely a running version of the image, right? And you can have the same image running in different places. So essentially, that's calling it. You can have the same image running at different containers in different places. They are different from each other, but they are also the same. Okay. Yeah, point is whatever copies you make from the images and whatever you're taking, that all the app, the dependencies, everything. So those are your containers. So whatever is running are your containers. Whatever they are based on are your images. All right. Right. Um, okay. Now, generally, when you want to take a photo, how are these photos? How do you say defined? They're defined by pixel, correct? So each pixel has a certain color and it forms to become that image, and they send that image to a builder and he takes in that information and builds it. Similarly, Docker has a system of its own called a Docker file. So the Docker file, they have something called layer. So what are layers? We will look into that. But essentially, what is in a Docker file is each of the command that you would actually run in a normal terminal, and uh, all of the app, like whatever command you used to install those app, whatever command you did to pre-configure that environment to your way, and everything to to get it working the right way. All right, those command are defined in the Docker file. We will look at one example later on as well, but just to get an idea of what a Docker file is, it's just a way of defining how that image should be built from layer by layer. So you have maybe 255 uh, layers of pixels, so each of those is one layer. Similarly, in Docker file, each command that you run is called a layer. The Docker layer, is not explicitly mentioned anywhere, but if you look around, the technical term for it is called layer. So each of the command, like uh, you just run mkdir, then a folder name. That can be one entire layer on its own. So like that, whatever software you're installing, all the apps that you're installing, each of those can be one layer. All right. Are you with me so far? Just a thumbs up. Okay, great. Now there are a lot of command in advanced Docker that you can use, but today we will look at some of the very fundamental one, some of the very basic one, right? So some of them are like most of them are on a screen, so we shall go over them one by one. Now, the very first thing that we define in a Docker file, maybe you want it on a base image, right? Suppose you want something running Python 3.11 specifically, or maybe something like Ubuntu 22 or 24. No matter what, you have some sort of base image. So this base image is what you call uh, using the from. This from command, you use it to call a base image. That can be anything that you want as a foundation. Basically, when you build an apartment, you want a foundation of cement, and then steel bars and everything, right? So similarly, a base image can be used, and that is called using a from and run. So, like I told, your layer, most of them will be comprised of run, because you will be running normal command that you would in a terminal, right? So if any of you have used Ubuntu before, you would type sudo apt install then whatever package name, right? Each of those can be called in a run command, and that becomes one layer. Okay. And cmd is another. It's not that important, but cmd is something that you can use. Say when you build a container, you can use that to start it in a certain way, right? Maybe you want some particular app to start first when you open the container. You can do that via cmd command. But point to note is this can be overridden by something else called a compose file. Your compose file, I will come to that, right? So the cmd is not that important, but if you want it to start in a certain way, you can use this. Then entry point, similar to cmd, but uh, this is fixed. It runs no matter what. So there, if there is something that has to be there no matter what, maybe you want some tube light in your room, that will not change wherever you go, right? So that becomes an entry point. You want the tube light there. So likewise, you want some app to run a command like a pre-setup or something, you can use entry point for that. All right. And then copy, yes, very important one. So Docker container by default, by worship, they are very isolated from your hosts. So what I mean by that is, suppose you have a computer running Ubuntu. Now you create a container for maybe say Debian. So that can happen. You can run different uh, CLI version of OSs using Docker. Now again, question will come: wasn't that a virtual machine? No, we will get into that at the end of it, but it is very different. All right. Now the copy command, what it does is, suppose you have some files on your host system that you want to copy it onto the Docker, like the container, because by default the container cannot see what is on your host computer. That is how it is built. And now if you want to copy certain file, you can files or folders even, you can use the copy command to do that in the Docker file. And while building it, it will copy it. And if you want to do something with those, you can do those as well. Okay. Now, uh, suppose when you enter a room, instead of having to set up everything, maybe make your chair the right height or everything, you want to just sit there by default by chatting when you run the container. So when you're in that room, you want your chair to be a particular way or anything, right? Similarly, if you want your container to chat in a very particular folder, maybe a home folder or a desktop folder or a downloads folder, you can specify that via the workdir command. We will look at that. All right. So workdir commands allow you to chart your container from a very specific folder that you define. All right. And this, of course, these are very few commands. There are a lot more, and I will send this PPT later on. But yeah, you can look at the documentation. I've linked it there as well. Okay. All right. Now I mentioned compose. What is compose? Uh, to relate back to a room example. Suppose you wanted your room to be in such a way that maybe windows open in a particular manner, curtains open to this much, then your lights on, maybe this light shouldn't be on, that light should be on, and then maybe your leg rests at the bottom of the table. You can define those, and if you had a way to define those, that in software, that would be your Docker Compose. The Docker Compose, what it can do is, it is actually used for multi-container setup. Maybe if you wanted like three different containers coordinating with each other to give out some common output, right? So Compose allows you to manipulate all of those different containers in a very coordinated manner. But for our use case today, we'll be just using one container. And what Compose allows us to do is, since the container itself is very isolated from our host, right? Maybe you wanted your display, or maybe you wanted your network, maybe like your laptop network to be accessible from the container. Maybe your camera, you want it to be accessible from inside the container. Normally, if you don't specify it, it doesn't care, it won't do it. But via a compose file, you can actually do that. And an alternative to compose file is, you can uh, define all of the terminal terminal flag one by one, but it's kind of very painful typing them out in the terminal every time. Okay, so you use a compose file for that, and it's very straightforward. I'll show you the commands in that as well. So this allows us to manipulate how we want our container to chat, basically. Okay, all right. So I think from this point onwards, I will go to the Docker file and show you an hands-on experience. And yeah, so whatever was told till now, is it clear? Right? Okay, great. So if you have any doubt, now is the time to ask. All right. Now there is a very specific reason I asked you all to have some sort of Linux uh, system for this, because Docker does not like to play well on Windows, because Windows has their own protocol and everything. So it's kind of very messy over there. So most people on Windows, they use some sort of Linux subsystem as well. So might as well start from a uh, Linux OS itself. So it can be a VM, or it can be a dual boot setup as well. But that is the reason why I asked you to join on a Linux based system, because then you won't have any problems running Docker. Okay, all right. So now I'll open my terminal. Okay, so I hope everyone can uh, see my screen. I think I've shared everything as well. All right. So Docker uh, images. Okay. So if everyone can run that, if there are no errors for anyone, then that means your setup is all right. Usually, if you have not pulled any images before, it will be like empty. That will be it will be an empty output with just the repository tag, image ID created, and size. So this is what you will see, and if you're seeing that, you're good to go. Otherwise, if you're encountering some error, now is the time to tell, because you need to do a you need to run a couple command so that you can actually uh, do this. I hope everyone is able to run it right. This as well as Docker PSA. So on your screen, I have run two commands. So these should return some sort of output without any error. So if there are no errors on your terminal, then you're good to go. Okay. So I will just explain what I did there. Now, of course, for your reference again, you can type docker double dash help, and it will output a bunch of command which you can look. But let's clear that out. Docker uh, images. So the very first thing that I mentioned, Docker images. So if you want to list out the images that you pulled or created on a system, you type this Docker images. Very straightforward, very simple, and you click enter. You'll be met with a list of images if you have pulled it before. Otherwise, it will be blank, and I'll make you pull a couple images as well. And another command is docker psa. So what this does is it allows us to see whatever containers are running currently, or whatever containers we have made from those images. So you can see I have an image called rig alpine, and of course I'll make you do this as well. But Docker PSA will return all of your containers which you have built from your images, and yeah, you'll be able to delete your docker your containers, and you'll be able to delete your images as well. I'll show you that as well. But docker psa is for containers, docker images is for uh, images. Okay, now let's get into uh, VS Code and open up a file called docker file. That's it, no extension, nothing, just simple docker file. Okay, so uh, I would like everyone to have a folder, and in that specify like make a file called docker file, and then later on docker compose.yaml. I'll tell you that, but first docker file. Okay, I'll give you a minute to open up a folder, then in VS Code, and then run this one docker file. All right, I hope everyone did it. Okay, so I'm not going to be typing anything here, but I expect all of you to type these lines onto your Docker file, and I will be explaining them one by one. Okay, let's start. So like I told, from, then you specify your base image. So for today I'm using a very lightweight Linux OS called Alpine. Alpine is a very minimal Linux subsystem with no GUI or anything. So it's very lightweight and it allows for, I mean, for today's tutorial, I wanted a very straightforward and fast setup. That's why I took Alpine. But you can type maybe Ubuntu or Python 3.11, maybe some other stuff like that. But for today, we'll be going with Alpine latest. So if you see here, you have the image name here, and then a colon, and then you type your version. So obviously you don't want the latest version of it, so I've typed latest. Okay. Now, like I mentioned, run. Run is where the bulk of your commands will be, and for today's sake, for brevity, I have kept it all in one run command. But you can split it up into different run commands if you wish. So what this does is, in Alpine there is a package manager called APK, and I'm running APK add Python 3, PyPip, and Nano. So I'm just installing Python, I'm installing pip, and then I'm installing a text editor called Nano. That is what this fourth line is. Okay, and usually if you want to have multiple commands in one statement or anything, you use a backslash for it. All right. So you can see two backslashes here. So that means I'm running a total of three commands here. Okay. So I install Python 3, I install pip, and then nano. Now the next line, I am making a config file called uh, etc profile, and in that I'm uh, specifying an alias called cls equals clear. So what this allows me to do is it allows me to clear my terminal with that three-letter word cls. Usually in Ubuntu or Mint, you would have something called bash rc, a dot bash rc. So that is what you would use to define all these aliases and everything. But for today's Docker, I went with Alpine, so they have a different profile file name. So I've typed it into that, and this command echo quote alias cls equal clear angle bracket, and into that this this allows you to, this command can be used for anything. You type your file name here, and this symbol is for appending, and then echo is to put it into that folder file, and then another backslash, and I'm making a folder called rig in home directory. So if you're aware, in Linux you have a home directory, you have a root directory. So I chose to make a folder called RIG in home directory, and that I chose to make it my work directory. So what this means is, when I start the container, I will be automatically put into home RIG. Okay, and CMD. CMD, again, like I told, something that can be overridden, but for uh, for chatting up a container, I wanted to run this particular command, right? So Alpine requires you to run this, so that's why I put it here. But you can run any other command. It could be Python, it could be some other command. But this is what you would want, to open up the container. So I'm opening a shell here, and I'm using CMD for that. Usually CMD and entry point. These are your always, these two commands will be at the end of your Docker file. Okay, because you want it to conclude with that, and all of your pre-setup like run, work there will be in between, but from has to be on the top. That is non-negotiable. and you have to define an image there. It could be your own image, and you will discover while you're using Docker that there are so many images for the uh, most of the things available. So if you ever wanted to run on a particular system or uh, another computer with the same setup that you had, you can configure a Docker file like this with a image and make this command. Okay, so I hope everyone has typed this. I'll send the file later on. So I hope everyone has typed it for me. Okay, can I get a thumbs up if people have typed it? And of course, no worries if you are not following along practically. Uh, Once you come to lab, we'll be making you set up a dual boot system because uh, virtual boxes are a bit overkill. It's very resource intensive, so we prefer you to just dual boot it, and it makes our own setup for our project a lot easier. So no worries if you're not following along, but if you're just here to listen to what is Docker and everything, no problem. Okay. So that's about a Docker file, and that is very simple. A Docker file is simply a file that you use to to define whatever command you want to run, whatever setup you want to do, whatever app you want to install, and everything. Okay. Now let's move on to compose file. Again, there's not much beyond this. I've kept it very simple, and yeah. So let's get into a compose file. What is a compose file again? It is a file to help you chart your content in a particular way so that you can uh, have the right device access, maybe your camera or your display or something. Because by nature, Docker is very isolated from your host, so it won't have access to your display, not even your network, not your cameras, not your USB devices, nothing. It's just bare on its own. So it is necessary that you give access to those uh, displays or network and whatever volume you want to give via this compose file. And I will go over this. There are a lot of components here. Okay, and there is a very distinct difference between Docker file and Docker compose. Docker file is to build your image from which you want to run your containers from. The Docker file is for images. Docker compose is for running containers from those images. Okay, I hope the difference is clear. Okay, uh, and in a Docker compose file, you have a version. By default, it is 3.8, so you don't have to worry about that. It's just the latest version, and all of your setup, all of your container running command have to be under this block, services block, and under those you make a this one. Yeah, so you make an image called rig docker test, and your base image is the one that you created from the other one from your docker file, and then build. So what build does is, by default, uh, your image is not built, right? So you want compose to build those images and then run it. So if that image does not exist already, it will build it for you, and then it will run the container. So under the build block, you have a context. Context is what? A dot. Dot again, like I told in the Git workshop, dot means your current directory. So if it find a Docker file in that in your current directory wherever the compose file is, then it just takes that Docker file and builds it. But otherwise, if your Docker file was in some other place, you would have to give it a path to the context. And Docker file, you're specifying a Docker file because By default, you name it as Docker file, it is convention. But if you, for some reason, decide to name it something else, then you have to specify it here. Okay. And container name. Container name, by default, Docker will give you a very randomized container name. It will be a combination of two random words, which makes no sense, but it's fine. So for your own convenience and organization, it's better to have a container name defined before. Okay. Now, till here was a part where you build the Docker image and container. But now, from this point onwards, you want your container run in a particular way. You want your room to be lighted in a particular way, or your windows to be open in a particular way. So from this point onward, you're you're defining this. Okay. And by my like, this is my own convention, but by default I want my laptop network to be the same on my Docker. Why? Because it allows for timeline to sync. It allows for me to use my network without authentication, and it just makes things a lot easier if you have to use network. So you just straight away give it your laptop network. So you define it as host. Host is the laptop on which the operating system on which your Docker is running. Okay. Then, like I said, by default your display is not given access to the Docker. So you have to specify that here via the environment block. So under environment, many other things are there, but for today's tutorial, I'm just defining a display. So this dollar symbol, then display. This is usually a Linux command. So if you actually go back to a terminal, I just want to demonstrate it. No need to follow along here. So if you type echo display, right, you can see that it outputs a colon and 0. So by default, this is your uh, this is the first display that it sees, that is system sees. So we are giving access to Docker display to this display. Okay. And yeah, then a bunch of volume. So what are volume? Maybe like, put simply, volumes are folders that you want mapped from your local system onto the Docker, right? So uh, suppose you wanted a water pipe linked to your new room and the old room. So you call this a volume. This link between something local and something in the container is called a volume. Okay, that is the bare bone definition of it. There is no other way to think of it. It's just a connection. Okay, always local first on the left, then Docker volume on the right. Okay, so within Linux they have this TMP folder and X11 Unix. So this is just for display thing. It gives you access to display. This is mandatory if you are using display. Okay, and then dev. So this is, suppose you have some USB devices connected and your camera, right? So you want to give those access as well to your Docker. So that is done via the dev command. And usually, let me demonstrate again. 1 second. All right. So if you type ls dev video, right? This command allows you to display whatever cameras you have active. So as you can see, I have two cameras active. One is my inbuilt one, and the other one is something else. That's like, if it's a stereo setup, you will have two cameras. But yeah, this is something. And then you have dev device. So again, a bunch of devices. I don't know what these are. Maybe printer devices or something. But the point is, there are certain devices that are given access to Linux via this dev folder, and I am giving Docker access to those devices as well, right? Because I want to be using my USB devices, my pen drive, or my cameras inside the Docker as well. Okay. No need to mind this another device thing again. Now the important part of the volume part, like I told you, it's a link between your local folder and something on your Docker. So what if you wanted something, you wanted a particular folder on your system to be accessible on the Docker as well. So if you created any files in any of these, it would be visible in the other. So volumes allow you to do this by defining a link from your local folder to your Docker folder. You have to define the path. With all of these are just path. Okay, and you might ask, how am I supposed to find the path now? Okay, you just go to your folder, then you right click property, and you can see here, right, location. So home slash predator, that is me, and this particular folder is located in slash home slash predator. Okay, so likewise you can get path for any other folder. So let me go back to VS Code. Okay, so yeah, this is your volume block, and it's very important if you want to give access to your devices, folders, display, right? Very important block to specify. Now, if you notice this privilege, you normally do not give access to privilege because this is allowing your Docker to have full access over your system, which is in some cases a security issue, so it's not very secure. Okay. So for the sake of this tutorial, I have given access to all my uh, devices under dev, so that requires me to give privilege true as well. Okay, but normally you don't give it like this. You define video 0 on either side, and then privilege false. Okay, because you have given access, that's all it requires, and then HCD open true and TTY true. So these both commands are necessary if you want a interactive command, interactive terminal, because by default Docker is a CLI application. It has no GUI on its own. Okay, so that's all about Docker Compose. Again, no problem if you're not following along. This is just for a demonstration. Okay. I realized I forgot to type the command that I'm using in the PPT. No problem. I'll update those and send it. You can try it on your own. Okay. But that's all about Compose. If anyone want me to hold it for typing more, just give a hand raise. Otherwise, I'll continue. So I know all of these may seem a little convoluted because why do you have to do all this to just install all the dependencies when you could do it by hand in different systems? It's just a more convenient way to do it, more how do you say collaborative way to do it, right? It's not necessary that you have to use Docker. Uh, Within the lab itself, we don't use Docker that much. Only for very specific use cases we use it because we want that, you know, the continuity between different systems. Okay. All right. So I'll move on to the terminal command. Okay. So I'll zoom in a bit. 1 second. Okay. I hope everyone can see it. Okay. Fine. So Docker PSA. You can see I already have a container running, which I don't want. I'll delete it. Okay. So you do that via Docker RM. Docker RM is remove or another Docker container RM. But shorthand is Docker RM. Okay. And you can type out the name reg alpine. Sorry. So that's the thing. That image you need to type the container name. My bad. So reg docker test. Okay. So you run this. It will remove that container. Okay. So now let me do docker psa again, and now see, this is what most of you will see when you are running docker psa for the first time, that there is no container. So this is your ideal output, and right now I've deleted it so that I can create a newer container. Okay, and docker images. So you can see that I have a couple images here, that is just for demonstration. I'll remove the rig alpine one because that is the one I'm going to demonstrate today. So the command for deleting images is docker rmi, and then you can type either the image name or the image id. I prefer to type the image name if they are unique, otherwise id is also fine. Okay, so it untags it, it deletes it. Untagging and deleting it, untagging because uh, by default when you create an image, it gives it a tag of like latest or v1 or v2, so which you can push to something called a docker registry. The docker registry again, I'll come to it. Okay, so I deleted my image as well, and docker images, docker psa. So both of these are gone. Let me navigate to my uh, all right. So as you can see, I have my docker file and docker compose YAML here. Okay, I'll zoom in a bit more. I think it's just small. All right, fine. So my docker file is here. I have my docker compose as well. Now I don't have an image. I don't have a container. So what do I want to do? I'll use docker compose to build the image as well as run the docker. Okay, so docker compose up build d. Okay, let's go over this command. Docker compose is the application that you're using, and up is to run it, and there's something called docker compose down as well to chop all running container. This is one option, and you have docker compose up to start the container and run it. Okay, and today I'm specifying a double dash build flag because I wanted to build the image as well as run the container, and I'm using a slash d hyphen d because it will uh, compose usually tend to get it tend to hang. So I just give it a hyphen d to detach it. So once it builds it, it will chop it. Let us see what it does. Yes, so as you can see, uh, yeah, so these are your layer, the blue line, each of them are your layer. So as you can see, the first one, load build definition from docker file, and pulling alpine. It's a little bit dark, so I don't think you can see it, but it pulled alpine, then it installs all of the packages that we define, then the alias, and then it creates a work there as well, and then it exports all those layers into one uh, single container. Okay, so so these are your layer. So there are very few layers here, that's why it built very fast. But usually in production grade Docker, you will find maybe hundreds of layers, so it will take quite a while. Okay, all right. So now let us see images. So you can see rig Alpine. Okay, and Docker PSA. The Docker PSA, it created an container called rig Docker test, and it was using the rig Alpine image which we had created via the Docker file. Okay, so now let us chart our container. Docker chart AI. Uh, what is it? Rig, wait. Okay, so if you can see this, it says that chat is it is up. So that means the container is running. So for that we will use, so to get into a running container, the command is usually docker exec it, then you type the like container name, right? And then this, 1 second. Okay, fine. So ignore this bin ss hyphen l, that is just for Alpine. But normally you would just run docker exec it rig docker test to get into an existing running container. Okay, the docker exec, it executes an interactive terminal. So that's what this hyphen it is for, interactive terminal. And yeah, so let us see what's it there. So as you can see, I'm within the docker now. I'm not in my terminal anymore. I'm not in my system's terminal anymore. I'm in the docker terminal. Okay, so I type cls. So you can see that the alias that I created before is what I had defined in the profile, and that allows me to use the cls command. Okay, normally you would type clear to clear up the terminal output. And now you can see that because I've given access to my network, you can see that I have an IP address which is belonging to my laptop IP address. Actually, it's the same one. So I've just given it direct access to that. All right. And you remember we installed Python as well. So Python 3, if we run that, we can see that Python is successfully installed, right? And then pip, we install pip as well. So that also worked. Beautiful. All right. So yeah. So now we have a running container. We have a working container with our required dependencies, with our required app and everything, all the access given, all the device access given. And this is the beauty of Docker containers. It allows you to have a very reproducible environment across different computer. Okay. And one more thing I want you to notice is, you remember I had defined a work there at slash home slash RIG. That is where it put me automatically. I did not have to navigate there. I did not have to do any extra thing to get there. Normally, it will start you off here. It will start you off at a very, it will start you off at the very beginning, the root. Okay. So this is what you see it. But because I specified a work there, I can do this. Okay. And of course, you can run whatever Python files you want now in this. You can run any system that you want, and then you can send this exact image to someone else. Okay. So, and if I wanted as well, I could have copied some local folder on my laptop onto this docker, and that would allow me to run the file within that. If they were Python files, I could run it directly within the docker. So this allows me to do that. Okay. And to exit a docker, you just type exit. Okay. So now I'm out of my docker content. Now let's see the PSA again. Okay. So now let's chop that container. Okay. So docker chop rig docker test. Okay. So as you can see, it takes a while because it's running, and then it eventually closes it down. Okay. So it output the name of the container that is chopped, and yeah, that's pretty much it. Let's go to the docker PSA again. So it tells you when you exited it. Okay. And yes, so that is your output of docker PSA. So now if I wanted to uh, like chart a container which is already charted before, then you type docker chart hyphen ai rig docker test. Okay. So docker chart is pretty self-explanatory, and this ai is again interactive, and the a flag was to chart, right? So yeah, so you can see that a means to attach it. So that interactive terminal will be attached to this particular terminal. Okay. So if I do that, so you can see now again I'm back where I was in the container without any extra problem. Okay. So yeah, that is a very brief intro to Docker. So end of the day, what is Docker? Just a simple way to uh, put your app, your required setup in one particular image, and you can ship it out to different people. You can make them do it, maybe start from the same file that you were working on, same thing. Okay, so that's all about the terminal action. We'll get back into a bit of, you know, uh, differences. Okay. Okay, now the question comes, why do I need Docker? Where can I use it? Okay, so the why I think was already well detailed covered. Okay, now about where you can use Docker, I've detailed it and I've reiterated it over and over across this call, uh, because it will happen that some package, some Python files will run on your system perfectly and not on your friend laptop. So to eliminate this very problem, even though you gave them the exact same file, they install the exact same setup, something or somewhere their system will be fundamentally different from yours. To avoid that, you use Docker. So you have no excuse to say that it works on my system, it doesn't work on his system. So that excuse cannot be used with Docker. Okay, if you have set it up properly, that is. Okay, if you have set it up, if you have done the Docker file properly. Okay, and like I told, very specific version. Maybe you wanted Python 2.7 for some reason. Normally, you cannot install that in a modern system. It will take some loophole to do it, and if you want to run some files, you can do that. You need to, you know, go around some uh, workaround. Maybe not only Python, some old software or some software which runs on only Ubuntu 16 or 18, but we have Ubuntu 22. Obviously, you cannot run that on 22. So use a Docker to initialize an image of Ubuntu 18, and then inside that we run the software. Okay, so Docker allows you to do this. If something is very outdated, or if we are outdated, if our computer is outdated, and we want to use an updated version, then Docker is there for you. It's your best friend here. Okay. Now, again, obviously there are some places where you should not use Docker at all, because it's just not very practical. Okay, and here is where the question of, like, why virtual machine exists come. Okay, once again, sorry. Yeah. Now again, like I told, you wanted Ubuntu 18, but you want the, you know, the GUI, all the default app, all the, like, the native Ubuntu 22 or Ubuntu 18 or whatever, right? So for this purpose, if you want that display, if you don't want to meddle around with permissions or some workarounds or giving access to something like that, you can use virtual machine for that. And Docker is absolutely not optimal there. Okay. Then again, you remember I told you that Docker is very problematic about seeing files which are on your system, right? So, so normally you would mount it as a volume and that would be it. But how it is with containers is they are usually not very permanent. They are not very persistent. So for this use case, I suggest you go with a native OS, or if you have to, a virtual machine. Okay. So storage heavy application. Suppose you want like multiple different folders across different location on your system. So for this, I don't think Docker is very useful. But if you have like one folder with all your configuration files, all your uh, files that you want to work with, you can use Docker for that. It will be happy. Okay. Then where you should not use Docker is, if you are questioning, like, if it ever comes to your mind, why am I even container? Why am I even making it a container? You probably are going to save yourself some headache by not using Docker. But again, experience will come. where you need to know where to use Docker and where not to use Docker. So again, it's fully practical. Once you come to the lab, you will find some of the other software like that. Okay, and yeah, generally, see today whatever I did was a very simple setup. It was very straightforward, but Docker is not very forgiving actually. It take maybe like 2 3 days if you don't know what you're doing, and you'll break your head trying to set it up, or something will not work, some permission will not be sent or something. So just to save you that headache, if you're even questioning why you're not why you're using Docker in the first place, then just forget about it. All right. Okay. So with this, we are at the end of it. If you wanted a visual, different kind of thing, you can have it here. Okay. And one important point I would like to highlight is this one. So in Docker, I told you have layers, right? So these layers, by default, they're immutable. Immutable as in you cannot modify them once they've been built. So then where are you writing your file? Where are you running your file? Those are on a separate layer called the writable layer. The Docker, once it builds the image, it will mount a writable layer for you so that you can run your file, maybe download your application, and that writable layer is what is being run in Docker. But when you compare it to a virtual machine, uh, it you can modify the OS itself. You can modify the OS file. You can modify the application. You can modify the file on the folders. Nobody will complain. So that is why you need to know where to use Docker and where to use a virtual machine. So if you want to be able to modify the OS at a very deep level, Docker is not going to help you there. And with VM, of course, like I told to many of you, it's a very resource intensive application, because that's like dedicating a part of your running system resources like RAM, storage to a separate different OS itself, and over time it becomes really heavy and it will considerably lag your system. You will be able to notice it. So if you want to avoid that, if you just want a very bare bones CLI application to run your files from the terminal, Docker is there for you. Okay. And one thing I want to clear up is when I give access to the display, it doesn't mean that you get to see the display of that particular OS inside the Docker file. I mean the Docker container. It means that whatever you want to visualize, maybe like a graph or matplotlib uh, graph, right? Those you can see on your laptop screen, not inside the Docker, because Docker by itself does not have an OS, or sorry, it does not have a GUI. So for that reason, you give access to your laptop display, maybe a graph or your camera feed even, right? So for those kind of application, you give access to your display, right? And of course security, VMs are way more secure because they have their own OS, they have their own file, their protocols and everything, so it's completely isolated there. And Docker, again, it's a matter of security because you're giving access to a lot of your app and your folders, then even your devices, which can become dangerous in the long run. You can't say. Okay, so in that sense it is less secure. All right. Then again, replicability is easier to replicate. You can just send the image to someone, they can build it, they can make a container out of it. Simple, done. It can happen in minute. But VM, you need to install the ISO file, you need to install the OS itself, then the app. It it takes time. Okay. So yeah, to conclude, uh, Docker is something that allows you to move around app, move around your particular file and your code base in a very predictable way across different computers. Okay, that is the bottom line. So I hope this was a bit informative, if not fully. Okay, so how many of you were okay with this? All right, all right, glad to say. So if you have any questions, please fire them away. I'll be hanging around here for a while. If you want to leave, you're free to leave. Yeah, we have done, and I'll be sending the command. You can run it on your own Docker, uh, like terminal. You can make your own images. I'll send the command for that in a while because I haven't actually done it here. So if you want to leave, yeah, that's it.